Assalamualaikum warahmatullahi wabarakatuh. My name is Nor Aida. My number is 41014211078. Here I will explain the project 1 about surjective, injective, and bijective function. I will explain about the process of drawing the function, and then I will prove the each of function. First of all, we must know what is the definition of injective function, surjective function, and then bijective function. I will explain it. First, a function f is injective if and only if whenever fx is equal to fy, then x is equal to y for all x and y in the domain.
Second, a function f is surjective if and only if for every y in the codomain there is at least one x in the domain such that fx is equal to y. And then the last, a function f is bijective if it is both injective and surjective. Next, I will open the GeoGebra application. First, I have a function fx is equal to 3x minus 2. We can see the graph. This is the graph of the function. Actually, for the graph, we can do the horizontal line test. If every horizontal line intersects the graph of f only in one point, it is called a injective function, like this. We draw the horizontal, we draw the horizontal line like this. We can see that the horizontal line and then the graph of function is intersect in this point, only in one point. If we draw the horizontal line, yes, we also get the intersects only at one point. But we can prove with the algebra method. Okay. Show that the function fx is equal to 3x minus 2 is an injective function, but not a surjective function. We can prove, we can prove that the function is injective. Let x and y is element of real number, where fx is equal to fy, we will show that x is equal to y. From the function, we can get fx is equal to fy implies 3x minus 2 is equal to 3y minus 2. And then we can get 3x is equal to 3y. Then if we divided by 3 in the left side and right side, we can get that x is equal to y. So it is proven that fx is equal to 3x minus 2 is an injective function. Next, we will prove that the function is not surjective. Let x is element to R. We want to show that fx is not equal to y. For the function, we get 3x minus 2 is equal to y, and then 3x is equal to y plus 2, because minus 2 is changed to the right side. And then we get x is equal to y plus 2 divided by 3. Next, let y is element to R, and then define that x is equal to y plus 2 divided by 3. Notice that x is element to R. We will show that fx is not equal to y. Fx is not equal to fy plus 2 divided by 3. It implies 3 times y plus 2 divided by 3 minus 2. We can get that y plus 1 minus 2, and it's equal to y minus 1. For this, we can find that fx is not equal to y, because fx is equal to y minus 1. So it is proven that fx is equal to 3x minus 2 is not a surjective function. Thus, fx is equal to 3x minus 2 is an injective function, but not a surjective function. I will the next function. The next function is fx is equal to x squared plus 1. This is the function. For the graph, we can also do the horizontal line test like this. If we draw the horizontal line, we can see that the horizontal line and the function, the graph of function, is intersect at this point and then this point. When we draw the horizontal line again, we also have the intersect of the horizontal line and graph of the function have more than one point. So we can conclude that the function is not an injective function, but it is a surjective function. Next, I will prove the function, use the algebra method. Okay. Show that f(x) is equal to x squared plus 1 is a surjective function, but not a injective function. To prove, we can prove that the function is surjective, like this. Let x is element to R. We want to show that f(x) is equal to y. For the function, we get that x squared plus 1 is equal to y. And then x squared is equal to y minus 1. So we get x is equal to root of y minus 1. Next, let y element of R and define that x is equal to root of y minus 1. Notice that x element R, we will show that
y. Fx is equal to y implies fx is equal to f root
y minus 1. It implies root of y minus 1 into bracket quadrat plus 1. So we get y minus 1 plus 1 is equal to y. So we get fx is equal to y. Then it is proven that fx is equal to x squared plus 1 is a surjective function. Next, we will prove that the function is not injective. Let x and y is element to R, is element of R, where fx is equal to fy. We will show that x is not equal to y. Okay, we can notice that when x is equal to minus 1, we obtain that fx is equal to 2. And when x is equal to 1, we have fx is also 2. Therefore, as fx is equal to fy and minus 1, it is not equal to 1. So it's proven that fx is equal to x squared plus 1 is not a injective function. So the function fx is equal to x squared plus 1 is a surjective function, but not an injective function. Okay, the next function, x is equal to 2x minus 1. Okay, we can see the graph of the function like this. And then I will prove the function. That is, it is a bijective function. For the graph, we can do the horizontal line test like this. And then like this. We can see it is intersect exactly 1 point.
Next, show that the function f(x) is equal to 2x minus 1 is a bijective function. We can prove the function is a bijective function when it is an injective function and also surjective function. First, we can prove that the function is injective. Let x and y element of R where fx is equal to fy. We will show that x is equal to y. Fx is equal to y, fx is equal to fy implies that 2x minus 1 is equal to 2y minus 1. We get 2x is equal to 2y and is equal to x is equal to y. So it is proven that fx is equal to 2x minus 1 is an injective function because we get that where fx is equal to fy, we get x is equal to y. Next, we will prove that the function is surjective. Let x element of R. We want to show that fx is equal to y. For the function, we get 2x minus 1 is equal to y. 2x is
equal to y plus 1. And then x is equal to y plus 1 divided by 2. Let y element of R. Then define x is equal to y plus 1 over 2. Notice that x is element of R. We will show that fx is equal to y. Fx is equal to y implies that fx is equal to f y plus 1 divided by 2. It implies that 2 times y plus 1 over 2 minus 1. We can get y plus 1 minus 1. It's equal to y. We get that fx is equal to y. So it is proven that fx is equal to 2x minus 1 is a surjective function. Thus, fx is equal to 2x minus 1 is a bijective function. Okay, I think it's all for me. Thank you for your attention, and I'm sorry if I have a mistakes. See you next time. Assalamualaikum warahmatullahi wabarakatuh.